This is our video on radicals, Unit 4, Day 8. Our objective is that we will be able to approximate, simplify, and explain radicals. Now, one of the most powerful things that we can do with radicals is that we have a calculator that can help you evaluate them. So when you guys come into class and we have the calculators, I want you guys to have a good idea of how to use all of these different steps. All right, so if you see something that says 2 squared, 2 with a little exponent 2, then you will press the number 2 here, and then you can use this button right here that's already kind of red, and that will square anything. All right, if this is not a square but maybe a cube instead, like this 6 cubed, 6 to the 3rd power, again you can press this number 6, and then this caret right here is an exponent, and then the number 3. All right, and then in the same vein, if we want to evaluate the square root of 78, the square root button, you need to press 2nd, and then above the x squared, you'll see a little square root. So click the x squared button, and you'll see the square root, and then you can click 7, 8. All right? And this one, it'll give you some sort of a decimal approximation. Here, I want us to take a second to complete the table below. So use the example for when A equals 2 and fill out all the other rows. All right, I'll do row number 3 just as another example, and then the other rows you should fill out on your own, as well as defining for yourself what is a square versus what is a square root. All right, so again, this is a square, and this symbol here is a square root. So define them in your own words going through this exercise. So here, if my A is 3, 3 squared is the same as 3 times 3, which is 9. Now if I do the square root of 3 squared, which is the same as the square root of 9, the square root of 9 is 3. One way you can think about that is what number times itself gives me 9? Well, I know that 3 times 3 gives me 9, so the square root of 9 is 3. Please make sure you fill out the rest of the table and define the following terms. Squares and square roots are inverses of each other. The same way that a plus and a minus are inverses, squares and square roots are inverses. If you want to find the area of a square, we multiply the length times the width, right? And when we multiply the number by itself, we say that we square that number. So for example, 5 times 5 is the same as 5 squared. When you take the square root of a number, you're like, okay, so if I had this box, this square here that had a total of 25, right? What would my side length be? And I know it has to be a perfect square. So if I had a square with an area of 25, what would my side length be? Now, what's really cool is we have these set of numbers called perfect squares. And perfect squares are the squares of whole numbers. So here, numbers like 1, 4, 9, 16, 25, all those in red are perfect squares. So you can figure out what all of those are because you do 1 squared is 1, 2 squared is 4, 3 squared is 9, 4 squared is 16, so on and so forth. Up until 144, you should have them memorized because those are part of your timetables. And once you have them memorized, it's really easy to estimate the square root of 50. Right? So for our first teacher example, it says the square root of 50 is in between which 2 integers? So what we know is that the square root of 49 is equal to 7. And we know that the square root of 64 is equal to 8. And that the square root of 50, right? 50 falls in between 49 and 64. So we know that the square root of 50 has to be between 7 and 8. Right? So the square root of 50 is between 7 and 8. Try your first student example on your own. Teacher example number 2 asks you to evaluate the square root of 78 and round it to the nearest hundredths place. So looking at the steps for doing square roots before, you'll find that the square root of 78 is approximately equal to 8.831760866 ... My hundredths place is going to be this value. So I want to have that many digits, 8.8 something. In order to figure out if I want to keep the 3 or if I need to round up, I need to look at the number next to the 3. In this case, it's a 1. 1 is less than 4, therefore I need to round down, which means the square root of 78 is approximately 8.83. So try student example number 2 on your own. Now our last teacher example asks you to simplify the radical square root of 120. Now here, similar to how we can simplify fractions, right? For example, we know that 2 over 4 is equal to 1/2. But we would rather write it in as 1/2 because that is a simplified version of the fraction. We can go through a similar process with radicals. So what you need to do is you need to find 2 factors of 120, so things that multiply and give you 120, where one of those numbers is a perfect square. So let's write out what our perfect squares are real quick. 1, 4, 9, 25, 36, 49, 64, 81, and 100. And now I can ask myself, okay, does 1 times 120 is not going to help me, so I should not use 1. Okay, but can I do 4? So I can do 120 divided by 4. Do I get a whole number? And you'll find, yes, I do get a whole number. So I can rewrite the square root of 120 as equal to the square root of 4 times the square root of 30, because 4 times 30 gives us 120. And here, I know that the square root of 4 is 2. So I have 2 square root 30. And now I have to ask myself, okay, 30. Are there any perfect squares that I can factor from 30? So is 30 divisible by 4? 30 divided by 4 gives me a decimal. Okay, what about 9? 30 divided by 9 also gives me a decimal. Okay, 30 divided by 25, also a decimal. So what you'll find is there are no perfect squares that is a factor of 30. So this is my simplified radical. So the square root of 120 is equal to 2 square root 30. But 2 root 30 is the simplified version, right? It is the version that you will be asked to write more often. So please go ahead and try this process with student example number 3. Okay, and then don't forget to do your reflection. See y'all in class.